Hi, my name is Ashley Perry and I'm doing this video tutorial on question 22 in the Chapter 4 workbook of Physics 111. I believe I'm in section 4. So the question to introduce, it asks, a 5 kilogram block has an acceleration of 0.20 miles per second squared. When a force is exerted on it, a second block has an acceleration of 0.10 meters per second squared. When subject to the same force, what is the mass of the second block? So to start, I like to just draw out all of the information that I already know. So we know the Newton's second law of motion is force equals mass times acceleration. And our mass is 5 kilograms, acceleration 20 and 10, and then we know that the force is the same. So then all of that information is likely that we're going to use F equals ma, and that's our best equation. So just to go over the given information again, we have the mass of the first block, which is 5 kilograms, the acceleration of the first block, which is 0.20 meters per second squared, and the acceleration of the second block, which is 0.10 meters per second squared. So to start, you're just going to find the force of both reactions. Since we only have the mass and acceleration of one part of the equation, then we're just going to start finding the force. So force equals mass of the first block times acceleration of the first block, which is 5 kilograms, times 0.20 meters per second squared. And then that's going to equal out to 1 newtons. And then if we look back at the question, you can see that they have the same force exerted. So then, since it's the same force, it's going to be equivalent, and we can use that 1 newton that we just found, place it back in, and we can use that to find the mass of our second block. So then that's going to be 1 newton equals mass squared times 0.10 meters per second squared. So then I just switched up that equation, multiplied the second squared times the 1 newton, and then have the mass on the other side so that it would be easier to just solve for the mass. So then that is 1 newton divided by 0.10 meters per second squared, and then that comes out to 10 kilograms. So the mass of our second block is 10 kilograms.